さんから、Ubiqu さんのソリューションの紹介になるんですが、先ほど質問に関して、オンラインでは、QA の機能で使ってやってくださいという話と、あと現地でもさっきパネルの時に、伺いますよというところを紹介したと思うんですけども、日本語で聞いていただいて構いませんので、ぜひですね、どうぞ質問いただければと思います。Next presentation is from Boris Goranov from CEO of Ubiqu about implementation of high assurance level implementation of EU digital identity wallet. Mr. Boris Goranov, floor is yours.
Thank you very much. So, just to be sure, can you all see my screen? So, thank you very much for giving me your time and listening to my explanation on scalable EU digital wallets and our experience with that. My name is Boris Goranov and I'm from Ubiqu. So basically, as Ubiqu, we envision that digital identities are key in digitizing the next steps in our development of digital transformation. What we see is that the EU is accelerating qualified trust services, and that means that with those qualified trust services, a lot of different markets are starting to combine into basically a new combination of digital interactions, and I will explain that later. What we see is that all these different qualified trust services will need eIDAS High compliant wallets. And these eIDAS High compliant wallets require sole control, and sole control means that we need some kind of hardware solutions. We already have a lot of use cases that have these kinds of hardware solutions in place, like passports and driver's licenses and car keys. For creating scalable solutions based on qualified trust services and enabling sole control for users, there are two issues that need to be solved to make it scalable and profitable. And one is we need remote unattended issuance of wallet and identity credentials so that you can do it at scale. And that means that you also need remote unattended identity proving. So what is a wallet? So if you dig deep into a wallet, the wallet contains a lot of components. So you have a mobile phone and you want to interact with other mobile phones. You want to interact with websites. You want to interact with TSPs so that they can issue credentials or attributes. So all the previous speakers have been talking about all those different issues. But then on the wallet itself, you need a user interface for the user so that the user are aware of what they're doing and what they're authorizing. But also you need the strong cryptography and the cryptographic components to tie everything with the user. So that means that there are two challenges for scale. So you have the cryptographic components. I'll be talking about that a bit more. And it's linking the wallet to an identity proving event. So when we look at the cryptographic components, with the state of the art currently, there are 5 different options that you can choose. And I will go through them one by one. So the first option is what we have been doing for years already, and we've been issuing smart cards to users. So what you see is that can be eIDAS 2 compliant on eIDAS High, but it's not scalable. we have seen that. That's why we're trying to do mobile phones and wallets. It's not user-friendly because you cannot use it for all devices. When something happens to the cryptography, you actually need to change the cards for the whole population, but it is independent of telcos or device manufacturers, and you can roll it out relatively fast. Then option 2 is basically using the trusted elements of the mobile phones or the embedded secure elements, but these currently are not all eIDAS High compliant. It is, of course, scalable and user-friendly, but again, the crypto is embedded into the mobile phone. That means that if something happens, then it's not usable anymore. It's not device or telco independent, but you can roll it fast, of course. But if you want eIDAS High compliance, you cannot roll it out really fast because you have to wait for the implementations of the device manufacturers. So if we look at the current state of certification, what we, for instance, see is that Apple has FIPS certification and ongoing FIPS certification, but only to iOS 13. Google has a Titan security chip FIPS certified, but currently only available on Pixel models. And those are, of course, not certified for the eIDAS High qualified signatures in Europe. Then Samsung has a chip that's available on a couple of models that's actually certified, but it's available on a limited number of models. That means that your coverage is really low and it will take decades to get sufficient coverage for national use cases. Then, of course, we can you can try the local secure elements are available from the SIM cards or the eSIM or the embedded secure elements. These could be made eIDAS compliant, but are not yet. You can roll them out scalably through the telcos. It could be user-friendly, but you are dependent on the device manufacturers for access. So from a robustness point of view, if something happens, you can roll out new SIM cards. But what makes it really complex is that all the telcos need to cooperate in order to have sufficient coverage. So that means that a rollout will depend on the eagerness and the cooperation of the telcos to actually implement this. Then, of course, you can try to do it in software, but that won't be eIDAS compliant. There are remote hardware security, so qualified signatures are remote QESs, but those still need an authentication solution. So the last option is that you have a remote secure element as a cryptographic backend for the wallets. That means that you have an eIDAS compliant solution that's scalable, that's basically user-friendly. If there's, for instance, a new cryptography available, you can upgrade to make that available to the remote secure elements. It's independent of the device manufacturers or the telco, so that means that you can independently roll it out. And as it is remote, you can do it really fast. So why does this work? There was a position paper from the GSMA recently that basically so the link is below, explained it really well. The concept revolves around separating the device key from the user cryptographic keys. So that means that you have the device on the mobile phone and you have the remote secure element in the cloud, and they both protect each other, and that's proven to be able to be certified on eIDAS High. Now, once you have a wallet that's on eIDAS High, you still need to issue to do a remote identity verification to enable to link the wallet and the identity credentials to a real person. So what does that mean? That means that, like Nick Pope explained, there are a couple of ETSI standards, and one of the ETSI standards details about which use cases are available for identity proofing of natural persons. And for eIDAS high identity proofing, that means that you need some kind of in-person high assurance of having identified the person. And there are basically 5 options. So the first one, of course, is having somebody physically present. The second person is what you call attended remote. So that means that you have a physical person verifying the identity of the person. And then the third option is unattended remote. And unintended remote means that you use artificial intelligence or other electronic means to verify the identity. And then the fourth and the fifth options basically leverage once you have a scalable digital identity, you can then use that to identify a person digitally, either with an EID, a national ID on a mobile phone, or a digital signature with a certificate. From a practical point of view, you need unattended remote for a scalable nationwide solution. So for instance, in Japan, if you want to do if you need to onboard 100 million new people, then physical presence will take years. Unattended remote will need hundreds of thousands of people to do the actual identity verification. And then 4 and 5, of course, is if you don't have a digital identity solution already, you cannot use that. So that means that unattended remote is basically needed to have a scalable and quick rollout to enable large-scale use cases. So that means that if you want an unattended issuance and an unattended identification, you also need to be able to read out an NFC cow ID document so that you can make a combination of an ID document, matching that ID document to a person and linking that identification event to a mobile wallet and a mobile phone. But in order to do that securely, that means that these 3 functions need to be combined into a single mobile wallet to do that at scale. So it's important that a wallet provider also will probably need to provide the NFC reading and the identity verification. What that also means is that if you want to do something like this at scale, then you really need NFC-enabled identity documents physically in the nation. So for instance, in countries where there are no large-scale identity documents with NFC capabilities for readout available, it will be really hard to scale these kinds of new identity technologies. On the other hand, it also provides opportunities where, for instance, if you do a national rollout of a physical national ID document, you can combine it with a remote issuance of mobile phones and remote attendance to then scale such a national ID card to scalable use cases. So to summarize, for creating a scalable solution, that means that you need to also do remote unattended issuance of wallet and identity credentials and remote identity proofing. And you also, of course, need a physical NFC-enabled ICAO document. At the minimum, but also you, of course, need other options for edge cases, but this will be the bulk of the work. So, but now let's zoom out. So let's suppose that we have created our scalable national ID document and we've rolled out our scalable digital identity. What does that mean? There are so many use cases that are already explained to our previous, from our previous speakers. So first, what you see is of course that we have all those physical secure elements in physical tokens that can now be put on a mobile phone at scale. So just to summarize, like I explained, so you, of course, are first doing a digital identity verification. Then you're doing a digital identity issuance on a mobile wallet to link a person to that digital identity event. And now you can start using that digital identity in all the different protocols, for instance, that Nick Pope was suggesting. Of course, you need a digital trust flow so that, and I'll explain to that later, so that you can build scalable systems, and you need the technology underlying that to make that happen. So I will now do a real world example where we're basically going to start from a physical identity document through a mobile phone to actually opening a physical door. So I am the holder of a national ID card from the Netherlands. And I can use that national ID card from the Netherlands to scan that with my mobile phone, match that biometrically. So now I'm the holder of the identity document in front of the mobile phone, and I can activate my wallet on my mobile phone. And now I have a eIDAS High enabled digital identity on my mobile phone. Now, using that, I can go to a website that basically manages the access to a door, log into there, and then enable Nick Pope, for instance, to be able to enter and to open my front door using his mobile phone. Nick Pope can now go through that process to have his identity verified, and then go to that actual physical access control system and download his tickets, and then open the door. So what has happened here is that at the first instance, the Dutch state is the issuer of the physical identity document, and then the identity service issuing the wallet was the verifier for that identity document and the issuer of the wallet and the credential and the PIN in the wallet. Now the access control service is the verifier of the wallet, but then is the issuer in an OpenID Connect protocol of an access token that's used by the website to verify my identity and give me access. Now, at that website, I, as the owner of a door, can basically authorize a new person and sign that authorization. So I am the issuer actually myself, and the signing service is the verifier of my authorization. Now, when, for instance, Nick Pope comes by and does the same thing and does his authentication, then he can go to the physical access control service, which then will verify the authorization of Nick Pope and issue to Nick his offline access tickets so he can actually open a door. Now, if combining all these open standardized protocols together means that you enable a chain that will tie back the opening of the door to the actual identity issued by the Dutch government. Of course, it depends on how you design the documents and the systems. If you can actually link it to the person, if the door knows who the person is, or it just knows that there is a secure link and it's a trustworthy process. Now, if we use this process on a different world example, we see that it really starts to live. So a real world example could be a real estate transaction where we have a buyer and a seller, which all undergo that same process. And then we have a seller and we have a buyer that can now digitally act. So now we have a contract for the sale of a house. So that means that that contract is signed by the real estate broker so that we know that the property is correctly described into that contract. But now we also, it would be really convenient that the seller of the house is also the owner of the house. So that means that we need a attestation that basically says that he's the owner. Then, of course, it is really convenient that the buyer actually has enough money to buy the property. So that means that he either has a bank mortgage or proof of means. And then, of course, for the bank, it's really important that the property has enough value to be to underwrite the value of the mortgage. So that means that you need a value appraisal from a value appraiser that's recognized by the bank. So depending on, of course, on local regulations, at the end of the day, this is more or less what a real estate transaction is. So if you combine all these elements, then the notary has a really easy job, and that basically verifying digital signatures of all the digital attested elements. And now also the land registry has a really easy job, because once the notary signs the complete package and gives it over to the land registry actually have their audit trail available, and they can update the land registry with a new owner. So what I was basically detailing here is what we are starting to call data provenance. So when we started with PKI 30 years ago, we basically ended up securing connections with PKI. So we have two organizations, and those organizations have their own compliance and their own policies, and they trust each other, so they make a link with each other. And they trust the connection, and then they trust basically everything what the other organization is doing. And what we have been doing with Zero Trust in the last 10 years is basically extending that concept, but from device to application. So that means is that we are basically creating a secure connection from the user device into the application that the user is using. And so for Zero Trust, we are basically saying we trust nothing and verify everything, yet we are not actually verifying the data that's going through those connections. So that means that when an application is connecting to another application, and requesting an API call for a certain piece of data, so the application that's receiving the request will give that data through a secure connection. But first, that application itself is, of course, secured. And that application will go through a secure connection to a secure database to get the data out of there. Then to that secure connection, it will be available to the application, and that application through the secure connection will give that to the application of the other organization. That other application is also secured and will go through a secure connection to a secured database and put the data there. But in the whole process, the data itself was never secured, and the security is implicit in the connections of the security of the connection, or the security of the application, or the security of the databases. So that means that if a hacker comes somewhere in between and can access the data, there's a problem. So what we are now seeing is with the eIDAS 2 regulation, there is happening something that you can start securing the data itself instead of only the connections. What then happens is that organizations don't have to have one-on-one connections anymore. They don't really need to set up these connections, but they trust qualified trust service providers who have identified organizations. And what now happens is that the holder, the user is starting to become an intermediate between the organizations. So that it means that you don't have to connect with every other organization in the world. You can interface with them through the user. And that means that we are creating a super scalable infrastructure to share data through the holder of the wallet as an intermediary to build scalable digital systems. In the previous example, every single step in the process, all the different providers don't actually need to organize and orchestrate. What needs to happen is that you need a standard on the data so that the data can be interpreted. But when the bank is issuing their mortgage offer and signing that, they don't need to coordinate with the land registry on how to issue that, or they don't need to coordinate in a specific system. It's same with the land registry. They need to just be able to give digital attestations. Now, what eIDAS 2 is doing is basically opening up all those authentic sources that are provided by the government to enable these kinds of interactions. So that means that what we want to introduce is the concept of data provenance. So that means that when you're using data, the only question you have is what is the source, what is the provenance of this data? What is the source of this data? And is that the correct source and the correct provenance for the data for my transaction or for my use case? So that means that for every data, you need to understand that there is an organization somewhere that is onboarded and identified and has received an identity and is able to sign the data and to enable the data provenance of the data. But what you can now also start doing is when you are encrypting, when you're doing scalable data exchange like this, you can also start encrypting the data and managing the audience of the data. But that's for another day to be explained. So I really want to thank you very much for the opportunity to explain our experiences in building scalable identity systems. And of course, if there are specific questions, I'm happy to receive them through Soshi.
Thank you very much, Boris-san, for your presentation about high assurance level implementation of EU digital identity wallet and also data provenance.